Hey guys, my name is Trevor Sullivan, and welcome back to the Stratus Grid video channel. Thanks so much for joining us for another video. Now, the topic for this particular video is going to expand upon a previous video that we actually had on our YouTube channel. So, on our YouTube channel, we have a couple of videos that cover the Amazon SQS service, a simple queuing service. And SQS is basically something that we can use from a Rust application or really any other application with a supported SDK, and we can send messages into a queue and then pick up messages off of those queues and process them. This allows you to have decoupled application architectures where you have a producer and a consumer application that are separate components and can be independently scaled based on the traffic demand of that application. So we have a couple videos. One just talks about kind of how to use the AWS SDK for Rust to interact with some of the essential SQS APIs. And then we have another video here that actually talks specifically about some of the different queue attributes that are available on SQS queues. But one of the things that we didn't cover so far is how to build an interactive application against SQS. If you're a developer and you're building applications in the Amazon Web Services cloud platform, and you need to be able to test out certain payloads and be able to just kind of send those payloads into an SQS queue just for testing purposes to make sure that the consumer application is processing those messages correctly, then it helps to be able to develop a little interactive CLI tool that you can use to send payloads into SQS interactively so that you can choose different types of values and things of that nature. So previously, when we had discussed the SQS APIs, we just kind of hard coded everything inside of the Rust application code. And obviously, that's not ideal because that doesn't give us a lot of flexibility without having to recompile the application every time that we want to change a value that we're sending off to SQS. That could be the name of the queue that we are creating or interacting with. It could be the payload or any of the queue attributes that we want to specify as we are sending messages into the SQS service. So it would really help us to be able to develop a really simple interactive CLI tool that allows us to feed in certain values kind of on the fly as we're interacting with the SQS service. Now, thankfully, the open source community out there has created a Rust crate called Inquire. It's from this person here, Mikhail Mello, who is allegedly a software engineer at Microsoft. And so this is an open source crate that allows us to capture certain inputs from a user interactively. There's several different types of input controls that are available. You can have a simple text input here, so I could type the name of maybe an SQS queue that I want to create, or I could type part of a payload that I want to feed in, or maybe a queue attribute or some metadata that I want to attach to a particular SQS message. There's also the opportunity to do things like date selection here. I can also do a select or multi-select option here. So I might use a select control to select from a list of SQS queues that are available in my AWS account. And I might use a multi-select if there's maybe multiple different pieces of information that I want to feed into my SQS queue message or something of that nature, or maybe certain pieces of metadata that I want to attach to an SQS message. There's also a confirmation prompt and there's a password prompt here as well that'll kind of mask input that a user types at the terminal. So if you want to use these controls here, like the select option here to select from a list of SQS queues, or maybe select a particular region where you want to list available SQS queues from, these types of controls can really help out. And then if you want to just type the payload for your message body here that you actually want to feed into the SQS queue, or even more specifically, maybe you're developing a custom data structure that needs to be serialized as JSON, and then that entire JSON string can be exported into the SQS message. You could also populate some of the individual struct fields using this text input option as well. So you have a lot of different choices here, but this just provides a really basic mechanism to capture user input so that you can reuse your application and make it a little bit more dynamic than hard coding everything inside of your application code. So we're going to take a look at how to use this crate and make things a little bit more interactive when you're building an SQS application. And hopefully you can use the same technique to build a simple application for your specific use case. All right. So the first thing that we're going to do is actually just spin up a new project. So you'll want to make sure that you have the Rust toolchain installed on your system. If you go to the website rustup.rs, you can install the Rust toolchain from here with this really simple script right down here. You can just copy and paste that into your terminal. And then once you've got the Rust toolchain installed, you can install the the Rust Up installer installed. You can do a Rust Up check here just to make sure that you've got the latest version available. It looks like I am maybe slightly out of date here. I'm going to do a Rust Up update to update my stable tool chain with the latest Cargo CLI, the latest Rust compiler, Rust C, and things of that nature. So once we've got the latest version of the Rust toolchain installed, and you also want to have VS Code installed as well, so you can go out to code.visualstudio.com to get the VS Code editor, and then you can install the Rust Analyzer extension, which kind of integrates with the Rust toolchain to provide auto completion and linting inline in your text editor and all that kind of stuff. So definitely makes writing Rust code a lot easier to have VS Code along with the Rust Analyzer extension. So after this is done installing all of the latest tools here, we're going to be actually using the Cargo CLI here just to create a new stub of a project. And then we're going to install all of our necessary dependencies. And so, of course, our dependencies are going to include things like the Inquire crate itself, which is available right here. You can see it is pretty popular here. It's been downloaded over almost 2.5 million times. And so it's pretty popular. It hasn't been updated in a few months, but I've used it recently for a couple of use cases and it works pretty darn well. And so we're going to be using this. We're also going to be using the SQS crate here. So we're going to be using the SQS AWS SDK SQS crate. And we're also going to be using the AWS config crate. So if we just do a search for AWS-config. This is kind of the core crate that allows you to do things like authentication and things of that nature. So this allows you to create a configuration with your region and your credentials and all that stuff. So we're going to be using this crate as well. And then, of course, the AWS SDK for Rust is all async. There's not, as far as I know, any kind of synchronous version available for it yet. And so everything is kind of driven by an async executor. And so typically we're going to be using the Tokyo executor here. There are other async executors available for Rust as well, like the small SMOL. That's an alternative async executor. I haven't actually tested that out with the AWS SDK to know if that works or not. So generally, you're best off just using Tokyo because it's very popular, it's very well supported, it's very mature, and as you can see, it's been used over 200 million times, so it's pretty darn popular. All right. The other thing we're going to be using is .env here. So this is going to allow us to import some credentials from a .env file. So that'll just allow us to separate our credentials into a separate .env file so that you can populate that file with your own set of credentials. All right. So to get started here, let's switch over to our CLI right here. And it looks like we've got the latest toolchain 1.80.1. So if we do cargo dash dash version, you can see we've got that version installed. Then I'll go to my Git directory. I typically make a Git directory at the root of my system drive here. And then I'll do cargo new. And then we're going to create a project called Stratus Grid SQS interactive, just to give it a unique name. And then if you have VS Code installed, you can go ahead and just specify the code binary and then pass in the path to that new project, and that will open it right inside of Visual Studio Code. All right, so the first thing we need to do is install our dependencies here. So we have our typical stub project where we've got our main.rs file here, we've got our cargo.toml file that has no dependencies in it as of right now. So we're just going to say cargo add Tokyo features full, and then we're going to do cargo add AWS-config, and we're going to specify features behavior version latest. There's a specific reason that we do that, but don't worry about that for now. Just make sure that you do that in your project. And we're also going to say cargo add AWS SDK SQS to make sure that we've got the SQS crate in here. I also like to add a crate called colorize. This just allows us to print out colorized text inside of a terminal environment. So I really like that one. And then we're also going to add the Inquire crate. So we'll do cargo add Inquire. And there's some optional features that are available in the Inquire crate here that are not installed by default. A couple of those things are things like the date picker. And if you want to have support for an external editor like Vim or something like that to interactively edit temporary files in memory, then you can do that as well. But we're not going to be using any of those features for now. We're just going to do really basic kind of text prompts and things like that. All right. So now that we've got our dependencies installed here, it's time for us to create. Actually, we need .env as well. Almost forgot that one. So we'll do cargo add .env, and there we go. Good to go. So I think that's all the dependencies we're going to need now. So we can go ahead and just install any others that we might need a little bit later on. Now, you'll probably want to wait for Rust Analyzer to kind of finish doing its indexing. That'll kind of generate all the auto completion stuff that it needs in the background for you. And that can be kind of processor and memory intensive. So just let that run. And if you're not getting auto completion, just give it a chance to finish all that stuff up. One of the first things that I'm going to do is to generate some AWS credentials. So I'm going to go ahead and open up an AWS window right over here so we can get logged in to the IAM service. So here's the AWS Management Console. We're just going to create an IAM user and generate some static credentials so we can authenticate from our Rust application using the .env file that .env supports. So let's go ahead and open up the IAM console here. We'll create a user, and I'll just call this SG Trevor SQS Inquire. We'll go ahead and hit next right here. We'll say attach some policies, and we'll look for the SQS full access policy here, and we'll just hit create user. Now we'll go to view user, we'll go to security credentials, and we want to add a new static access key here. There are other ways to authenticate as well using things like single sign-on and whatnot, but this is generally the easiest way for anybody who's kind of new to AWS. I'm going to copy the access key and the secret key right here. We're going to create a new file in our project called .env. This is the file name that's going to be searched for by the .env crate by default. So we'll do AWS access key underscore ID equals, and we'll paste that. We'll do AWS secret access key. These are special environment variables that the AWS SDK recognizes. And then we'll set AWS region equal to US West 1 for now. Let's head back over to the console here and just check the SQS service to see if we have any SQS queues here. Otherwise, we'll have to probably create one. It looks like we have a couple here, but we could always create additional ones as well. So these are standard queues. You can also create FIFO queues. You can customize some of the queue attributes. And again, I would encourage you to go back to our YouTube channel if you're interested in any of those queue attributes or just getting started with the SDK for SQS from Rust in general. But for now, we do have a couple of SQS queues here. So one of the first things that we're going to want to do is to set up authentication for our application to the AWS SDK. So down here, we're just going to say, let's create a new AWS configuration. So we'll say AWS config, and we're going to do a load from env. And then we'll go ahead and await that because that's an async operation. We also need to add the Tokyo main attribute right here. And we need to turn our main function into an async function. Because generally speaking, if you're building an AWS application and you're using async, you're probably going to want to turn your main function into an async function. There are ways that you can use Tokyo to do async without having to turn your main function into an async function. There's a block on function or something like that that allows you to kind of create a blocking thread at the root of your main function. But we're just going to use the standard approach here where we basically kind of apply the attribute for I should say annotate the main function with the Tokyo main attribute, and that allows you to have an async entry point here. All right, so let's go ahead and assign the AWS config to a variable right here. And the other thing that we need to do is to load our environment variables before we attempt to call this load from env function here, because this is going to be looking at those special environment variables to set up authentication. So let's go ahead and use the .env crate right here, and we're just going to call .env. So that's going to go ahead and say, let's do .expect here as well, and say failed to load environment variables. So that should load everything as environment variables into this process. And then on the next line here, when we actually call load from env and await that, because that is an async function, that should ultimately read those environment variables and allow us to authenticate to the AWS SDKs. Now I'm going to go ahead and bring in a use statement up here, and we're going to use the SQS crate as SQS for short, just so I don't have to type out that full crate name right there. What we're going to do first is just validate that our credentials are working correctly. So we'll do SQS and create a new client here. So we'll say SQS client, new, and we're going to borrow the AWS CFG variable there. And then we'll say SQS client variable is equal to that client data structure. So now we can call all the different SQS functions from there. So let's go ahead and go down here. We'll look for the SQS crate right here, and we can pull up the documentation for it. So we're going to go to docs.rs for this particular crate, take a look at the client data structure here. And so these methods here all align to the various REST APIs that are available in the API reference. So these are kind of the Rust method names, but ultimately we're calling the REST APIs that are available in the AWS REST API documentation. One of the first things that we'll want to do is to call the list queues function here, because that doesn't really require any input arguments. All we have to do is say, hey, show me all the queues that are currently available in this particular region. And then what we can do is just print out that list, and that will validate that our credentials are working correctly, because we should be able to see the list of SQS queues in the US West 1 region that we specified in our .env file right here. So let's go ahead and do SQS client dot list queues. And with all of the AWS SDKs, we have to call the send method on them. And then we have to call the await keyword on that because it returns a future. When you call .send, that returns a future. So we have to await that future in order for it to actually execute that code. So let's do let queue list equal this list right here. And then we'll go ahead and just enumerate through those. So we'll say for queue in queue list. Let's do queue underscore list. Sometimes the autocomplete doesn't quite work the way I expect it to. So we'll do queue list dot unwrap right here. And so then after we unwrap it, so we should have list queues output dot and then queue URLs. So if we take a look at the list queues output data structure, let's say list queues output. And if we take a look at the list queues output data structure right here, you can see we have this public field called queue URLs, and that's going to have an option type kind of wrapping it. We'll have to unwrap the option, and then that will ultimately give us the vector of strings, which are the individual queue URLs that are available. What we'll do is grab the queue URLs, but then because that gives us an option, we actually have to unwrap that as well. And that is ultimately going to give us the individual strings inside of that vec. So now we can just say print line found queue URL, and then we'll just put in a placeholder here and pass in the queue variable. And I'm going to go ahead and take the queue variable since that's a string, and let's bring in the colorize ANSI color trait. And by importing that ANSI color trait, that's going to give us access to a bunch of methods on strings. So I could say like dot green or dot, yellow or something like that. And so basically we're just going to format the queue URL that gets substituted for this placeholder here as yellow text instead of just standard white text. So let's go ahead and give this a try. Let's do a cargo run right here. And this is just going to validate that we're able to authenticate successfully. And then we'll go ahead and add in some interactivity into this application by using the inquire crate. So we want to prompt the user and say, hey, out of these queue URLs that's available in this region, which one do you want to select, right? Where do you want to send a message to? And so we can use the inquire select control to prompt the user to select one of those queue URLs from the list that we are generating here. All right, so here we go. These are the queue URLs that we found in the US West 1 region right over here. So the name of the queue just gets appended onto the end, and so that entire queue URL looks something like this. This is working great, and the queue URL is actually used as an input to other API calls. If we call the send message API, then we need to know what that queue URL is as an input to the send message function so that we can specify which queue we are sending a message into. So if we take a look at the client data structure over here again, so under the root of SQS, take a look at the client data structure. There should be a send message right here. And so send message is going to take in inputs like the queue URL and the message body, message attributes, and things of that nature in order to specify where to send it to, right? Because you have to tell the message which queue it's going to be sent to. So now what we can do is prompt the user for a list of queues, and then the user can select one using one of those select controls. So to do that, what we're going to do is comment out this code here that iterates over them because we don't want to consume that value. So what we want to do instead is to prompt the user with the vec that we retrieved by doing QList unwrap queue URLs and then unwrapping that from the option. And that's ultimately going to give us access to that vec of strings that we can then prompt the user with. So we'll say inquire, select, new, and this time when we use this new function here, we can specify a prompt message. So we're basically just going to tell the user, please select a queue from this list. Please select an SQS queue to send a message to. That'll be our static prompt there. And then the other thing I like to do sometimes is say let prompt message equal this, and then this just kind of shortens up our line right down here by defining that as a variable instead. So we'll say prompt message. And then for the options here, this is the list of options that the user can select from. So you could do something like let option list equal, and then use the vec macro here, which is built into Rust, the standard library. And so we could use a vec and say, option one, option two, et cetera, and then pass in option list as a list here. And then we could call the prompt function to actually invoke the prompt. And then we could say let selected item equal the result of that. And that is going to allow the user to select from this static list here. But in our case, we don't want a static list, we want a dynamic list. And so that's why we are calling the list queues API here to dynamically retrieve a list of SQS queues rather than having to hard code a bunch of options into our application. So since this is likely the first time that you've been seeing the inquire crate here, let's go ahead and just try to run this so you can see what that actually looks like. And I'll also just say print line, you selected the X item, and then we'll pass in selected item as an input here. And of course, we need to unwrap it because this is a result type here. We'll just say dot unwrap. All right, so let's do a cargo run, and we should be prompted with a select option here. So now we can use the up and down arrows to say, all right, do you want option one or do you want option two? So now it just says down here, you selected the option two item. If I run it again and just choose option one, it says you selected the option one item. So that's essentially how this control is going to be working. But instead of hard coding these options, we're going to remove that. And instead of passing in option list over here, we're going to pass in the queue list and then unwrap that from the result. We're going to grab the queue URLs property or field, I should say, from that data structure. And then we're going to unwrap the option from there, which gives us the vec of strings. So let's say queue list dot unwrap. Actually, I'm going to put this on a separate line since it's kind of involved here. So I'll say let queue list, and we're using variable shadowing here because I already declared a variable like that. But we're just going to shadow the variable. This is a Rust feature that allows you to kind of redeclare the same variable with a different data type. And so we'll say QList unwrap, and then grab the queue URLs field and unwrap that from its option type. And then down here, we're going to pass in the queue list, which is a vec of string types. And so that's going to give us a result type here. And then we could change this to say you selected the X SQS queue. And this time we'll say selected queue as the variable instead, just to give it a slightly more relevant name. And we'll say unwrap that from the result, and then we'll say dot red just to color that a little bit differently than the rest of the text. So now when we do a cargo run operation here, you can see that we get this select option where I can just use the arrow keys to select which of these SQS queues I want to select. And as you can see, it prints out the SQS queue in red and the rest of the text in standard white. All right, so now we've implemented an option to select which queue we want to send a message into. We also need to be able to specify a payload, right? So to specify a payload, in this case, we're just going to use a plain text payload, but you could use the SERDI library to take a custom data structure and then encode that as JSON, and then pass that JSON encoded string into the message body, because likely your application is going to use some kind of data structure like JSON in order to pass in different data fields, right? But in this case, we're just going to keep it really simple and just pass in some plain text. So now we're going to say, let the body, maybe message body, equal inquire. And this time we're going to use the text input control rather than the select input control that we used up here, because we want the user, in your case, a developer, to be able to pass in arbitrary text. It will say inquire, text, new, and with the text prompt, the only thing that we have to pass in is a prompt message. So I'll go ahead and just duplicate this variable from line 15. We'll do shadowing and say, please enter an SQS message body, and we'll pass that in. We'll say borrow prompt message, and then we need to call the prompt function to actually invoke the prompt, and then we get the result type wrapping another string. So then down here, we'll say sending message body to SQS queue, and we'll just pass in the message body dot unwrap, and then we'll do dot red, just so we can see that in a slightly different color. Okay, so now we'll do a cargo run, and we should be able to start by selecting an SQS queue. And then the second option that we have here is to enter a message body. I could just say like name colon Trevor, and now you can see we have sending message body to SQS queue, and this is the payload that's going to get sent into the SQS message body. Now you could add additional prompts here as well. If you wanted to add some custom attributes as well, you could allow the user to, specify some attributes that they want to pass in. And I would encourage you to take a look at the documentation for some of the different attributes that are available. You can use this message attributes feature right here, or this is a method that you can do to pass in a particular message attribute and a value that you want to pass in. This talks about all the different types of attributes that are available out there. And we also have a different video on our channel that actually talks about SQS message attributes as well. So feel free to check that out. But for now, we're just going to keep things simple and pass in a simple message body here. All right, so now what we're going to do is go ahead and put this inside of a loop. So after we create the SQS client, I want to put a loop starting here so that if we want to send multiple messages, we don't have to run our application multiple times. Instead, whoops, let's do a remove there. And then down here, at the end of this, after we send a message, we want to go ahead and just put this inside of a loop. And so what this is going to allow us to do is to just continuously loop until the user exits the program. And so one thing that you can do with the inquire crate is if you do cargo run, if you encounter one of these prompts that pauses the execution, you can just hit the escape key, and that will cause your application to panic. And so that panic is going to cause the entire process to exit, and we don't have to worry about breaking out of the loop manually with some application code. Another option that you do have, though, is to inspect the value that the user returns and maybe say if the value that the user enters is Q or maybe E or the literal word exit, EXIT, then you could say, okay, well, obviously the user wants to exit, so I'm going to go ahead and break out of the loop. So what we could do is grab the selected queue here and go ahead and unwrap that value. And then what we'll say is if the selected queue is equal to exit, then we'll go ahead and just break out of the loop early. Otherwise, we want to go ahead and use the selected queue and print it out right here. Okay. So now if the selected queue is equal to exit, if we were to choose exit as an option there, then we could exit out. The other thing we could do is, since this is not a plain text input field, what we could do is actually change this to, let's actually leave that there. And because this is a plain text field down here, we could actually just go ahead and specify this right after the message body. So we want to do message body is unwrap. Let's do let message body equal message body dot unwrap. And then we'll say message body. If that equals exit, then break. Otherwise, go ahead and pass the message body into the print line statement here. All right, so now we won't be able to do that in the list of options that we have up here because this vec is actually coming back from queue URLs, and we could make that a mutable vec if we wanted to. We could say let mute queue list and just turn that into a mutable vec, and then we could say, queue list dot push, and we could push an extra item to that vec. But for now, we'll just keep things kind of easy and make it part of the plain text field down here. So now, if we do cargo run, then we can specify a queue from the list here. It doesn't matter which one we choose. But if we type exit at the SQS message body, then our application gracefully exits. And so any code that we put after the end of the loop, which is right here, we could just say print line gracefully exiting application. You could do any kind of cleanup that you might want to do, like maybe clean out the queue from any pending messages or anything like that. Let's go ahead and try that again. Say cargo run. Choose any queue here, and then just type exit. And as you can see, we are now gracefully exiting the application. All right, so now that we've implemented that functionality to kind of gracefully exit out of this infinite loop that we have right here, we could also put a help statement here and say to exit gracefully, type exit at the body prompt. And then we'll go ahead and just do a placeholder here, and we'll pass in dot red just to emphasize that help statement a little bit. Now when we do cargo run, that should be printed out right before we enter the loop. Okay. Just making things a little bit more user-friendly here. So now the last thing that we need to do is to actually implement the ability to send the message. That's kind of the meat of what we're doing here. So at the very end of the loop statement here, we will go ahead and use the SQS client to call the send message function. And of course, we need to do .send.await, and we'll capture the result. So we'll say let send result equal the output from the result of sending this message. And of course, in order to send a message, we have to specify the queue and we have to specify the message body. So we'll say .queue URL. And again, this is part of the input type here. So we've got the send message fluent builder type, and these functions that we have right over here allow us to customize the operation before we actually call the send function to generate the future and then await that future. So we are calling the queue URL, which takes a string, or anything that can be implemented as a string or converted into a string is supported here. So as long as it implements the into string trait, we can pass that in. And as long as we specify the message body here, which also takes anything that can be implemented or converted into a string, that should work as well. Just keep in mind that there is a maximum size of 256 kilobytes. So if you're uploading a file that maybe you're reading from the local file system or something like that, there is a size limit. So you're not going to want to store arbitrarily large binary files in here. You're not going to store like large PNGs or large video files in there. That's just not the appropriate use case for SQS, generally speaking, unless they're like really small files. But even then, that's not really the intended use of SQS. Generally speaking, you'd upload a binary blob to S3, and then you would just pass in like a URL that points to that object in S3 in your SQS queue here. But in any case, we'll specify the queue URL as the selected queue. So we'll go ahead and say selected queue. And you can see it says use of moved value. That's because we are consuming the selected queue up here. We should just be able to borrow that up here instead. And so let's do selected queue, unwrap, and let's go ahead and try to compile this and see if this works. And so it looks like this is still not going to work. So what we actually want to do is clone this value instead. So we'll say selected queue, and then we'll actually clone it right here. And that should avoid consuming it rather than borrowing it because of how this red function is working with the ANSI color trait that we imported from the colorize crate right up here. The other option is we could just comment out that print line statement, but if we want to keep it, then we'll need to clone it right there. And then the other thing that we need to do is specify the message body. So the message body, again, is just going to take anything that can be converted into a string, anything that implements the into string trait. And so now what we're going to do is just take the message body, but we're going to probably have to clone that here as well since that's being consumed. And then we'll just pass in message body right here. All right, so now we just want to check the send result. So if the send result dot is okay, then we'll just print out a statement that says sent message to SQS queue successfully, exclamation point. And we'll go ahead and make that green. So we'll put a placeholder here and then call the green function on this string over here. And we could do an else statement and say print line failed to send message to SQS queue. And we'll just make that a red color just to make it a little bit more visible as an error. Okay, so let's go ahead and try things out once again. We'll do a cargo run right here. We get our little help message printed out here. We can select a queue. So I'll choose the Rust test 123. Now we enter a message body and we'll say hello from Rust. And it says sent message to SQS queue successfully. And so things just loop around again. So after we send a message or fail to send a message, it just loops around again infinitely so we can continue to send messages. So I'll choose the same queue again and say hello from the crab, the Rust crab. And as you can see, it sent message successfully again. So we can just continue to iterate here, send in test payloads into our SQS queues and make sure that our consumer application is processing these messages successfully. So we've built out a nice little interactive CLI tool here that helps us to kind of test out our SQS-based applications from the producer side and then make sure that our consumer is kind of working as we expect, right? By maybe monitoring the logs in CloudWatch or something of that nature. All right, so I'm going to go ahead and just choose a queue and then type exit here. We'll gracefully exit our application. And now to validate that everything is actually working, I'll come over to the AWS Management Console. We'll say send and receive messages. And down here in the bottom section, we have received messages right here. So we'll say pull for messages. And as you can see, it looks like we have a message here and it says hello from the crab. So that looks great. And I'm not sure what happened to the first message. Maybe there's something else that's pulling the application here, but we were able to see that message. Let's go ahead and try to send another one really quickly. We'll do Rust test 123 and say hello from Rust. It says it sent successfully. And sure enough, it's still pulling back there. So this message right here is hello from Rust. So I must have some other application that's continually pulling back there. I'm not entirely sure why that first message aged out, but we were able to send in another message here just fine. So basically, you can continue to kind of iterate on this if you wanted to. Another option that you have is to prompt for a function. So if you want the ability to send a message to a queue to just be one of several different functions, maybe you want to be able to read a message off the queue in addition to being able to send messages into queues. So what we could do is prompt the user with a list of operations that we support. We could say let operation list equal a vec here. Probably want to put that outside the loop because we don't need to reprovision that each time or reallocate that. So we could say send message to SQS queue. do a comma and say receive message from SQS queue. And we can just kind of formulate a list of different items that we want the user to be able to perform here, right? So now we have this operation list right here. And so on every loop, rather than just implying that we want to be able to, send a message to a queue, we could let the user select a queue and then say, based on that queue, you want to send a message? Do you want to receive a message? What do you want to do with that? And so what we could do is set a match statement here, and we actually want to prompt the user first. So after they select a queue, we'll go down here and we'll say match the selected queue. And then if the selected queue dot toString, we want to turn it into a string so we can do a comparison down here. Actually, we may not need to do that. Let's just try using it as a borrowed string for now. We'll say if the requested operation is this, then we'll do a fat arrow, put our colons here, or our braces rather, and then we can, let's do a .toString here. I think it is doing some kind of conversion here. It expected a string and it found a string. So let's try .toString, .toString. Not entirely sure what is going on here. We should be matching. Oh yeah, so we have this is a string, and so we want to turn this into a string. So what I'm going to do is just call .toString right here on both of these values. That'll give us a vec of strings rather than borrowed strings, string slices, I should say. So now we'll go ahead and do a comparison to this. Can I call toString here? I don't think I actually can. I think I can wrap that in either parentheses or potentially curly braces to actually do that though. And so I'll have to figure out how to do that exactly here. But essentially, what we want to do is look at the selected operation. Actually, that's what I'm doing totally wrong here, is I want the selected operation, not the queue. So what we'll do is say let operation equal, let selected operation equal inquire, and then we'll use a select type here. We'll say new, please select a queue operation, and then we're going to pass in the list of options from up here. So I am actually going to remove .toString here. We want to keep those as string slices because we're doing static comparisons to those. And so what we're going to do is pass in the operation list dot prompt. And so now we're creating a new select prompt. We're passing in the list of operations that we declared earlier as a vec of borrowed string slices, and then we're going to prompt. Now, this is a pattern match, so we can't actually call a function there. And so what we need to be able to do is to unwrap the selected operation. So let's do .unwrap here. Let's actually do .unwrap right up here instead. And then it's saying that we don't have an exhaustive list because we did not match the other item here. So let's go ahead and say receive message, and we'll pass in a match arm here. And then we want kind of a catch-all. So we'll do a wildcard with an underscore, and we'll say print line, you selected an invalid operation. Okay, so now what we can do is basically say if we want to send a message to a queue, then we can take all of this code right here and go ahead and move that into the send message block here. And so now if we choose this operation, it's going to run all this code to send a message to the queue, or down here, we could write some code to receive a message from the queue instead. So what we could do is say, let's do SQS client dot receive message dot queue URL. And we're going to use the same selected queue that we did previously to put a message onto the queue. We'll say .queue URL .send .await, and let's say receive result. And then we'll say if the receive result dot is OK. Then we'll go ahead and print line and say received payload or body is X. And then we'll grab the receive result dot unwrap. And let's see, that'll give us a receive message output. So then we'll grab the messages. That'll give us an option of messages. We'll go ahead and unwrap that. And then we'll say, all right, we now have I think that'll give us a vec of messages. So let's say let message list equal that. I'm going to use the Rust Analyzer extension to kind of help me out here. That's going to give us a vec of message. And then we'll say dot iter dot next, and that should just give us the first message there. And then that's going to give us an option. So we need to unwrap that as well. And so then we'll go ahead and take that message and say message list dot body. And then we'll go ahead and unwrap that as well, because the body is actually an option as well. Now it looks like we're going to get a little bit of an error here. So let's do messages unwrap. And then we'll say let first message equals the message list dot iter dot next dot unwrap. Sometimes you have to put things on separate lines because it drops a value while you're still calling other methods on it. And so if we split that across a couple of different lines here, that should work just fine. So then we'll grab first message dot body dot unwrap. And it looks like we cannot move out of there. So let's try borrowing it and see if that is going to work for us here. And if not, it suggests calling dot as ref. So let's try doing first message dot as dot body dot. Let's see if we can figure out where to grab a reference to that. So on the body here, if we say as ref and then unwrap that from the referenced element there, we are able to pass it in. All right, otherwise we'll say else print line failed to receive message from the SQS queue. And I'll go ahead and make that a red message as well, just to call out that error a little bit more obviously. All right, so we are receiving a result. I think we can also limit the number of messages that we receive. So max number of messages, we'll just say 1. So we can only ever receive 1 message at a time. And so let's go ahead and hit escape here. Let's try another cargo run here. And it looks like the operation list is being moved. So we probably need to reference that instead. Let's go to our problems list right here and see on line 29. Here's the operations list. So let's see if we can just borrow that instead. It doesn't look like it's going to like that because it does not allow us to do a borrowed vec. So let's just do a dot clone here instead. So every time that we loop, it's going to clone that vec and pass it in. Okay, so let's do a cargo run here again. That'll recompile our application. Now we can choose an SQS queue. So let's do rust test 123. We'll choose the operation to send a message to the queue, and we'll say hello from Stratus Grid. So we sent a message to the SQS queue successfully. I'll choose the same rust test 123 queue, and now we'll say receive a message from the queue. And as you can see, it says hello from Stratus Grid. Now, the other thing that we would need to do here as well is to actually delete the message from the queue. So when you're dealing with SQS, as you may know from the original video that we did on SQS, when you receive a message, you get something called a receipt handle. And so you actually have to process the message and then delete the message from the queue by using that receipt handle. Otherwise, the message will get put automatically back onto the queue for another processor to pick up and process. So if you successfully process a message from a queue, you have to also do the delete operation. Otherwise, it'll just continually get put back onto the SQS queue. But I'll leave that for you to go ahead and do as a separate exercise here. The point of this video is really just to show you that you can use the inquire crate here to prompt for a list of SQS queues. You can prompt for an operation that you want to perform. It could be to create a new queue. It could be to delete a queue. It could be to maybe change a queue attribute or something like that. And so you can basically manipulate the entire SQS service by using an interactive CLI tool that you wrote in Rust rather than having to use the AWS Management Console. So hopefully you see some value in this and you can build an application in Rust that is valuable to your specific use case and prompt for all of the appropriate inputs to feed into your SQS queue operations. So thanks so much for watching this video. Again, my name is Trevor Sullivan, a solutions architect here at StratusGrid. I hope that you learned something new out of this video. And until then, we'll see you in the next video. Take care. Thanks.